Thanks, Leif. I think we're going to learn a lot of internet things, maybe, right? The Internet of Things. That's what this talk is about. It's not only about the Internet of Things, but the whole point is to kind of understand how the Asterisk PBX landscape unifies or comes together or can be useful for the IoT landscape as well. So in this sketchy hour, using the phrase by Dave Dufay, or Dufay, we'll be looking at these topics. We'll start with getting a definition of understanding what IoT is and seeing some platforms, hardware and software platforms, examples of that, just to appease the business crowd and maybe convince the manager folks and the bosses that IoT is important also for PBX and SIP proxies. Take a look at the marketing potential and what some of the security analysts are talking about, industry analysts are talking about. Standards, applications, hardware and software. We have a whole variety of examples here you can look at. Interfacing with AMI, actually ARI would be a better choice, but we'll be taking a look at that. And then at the end, some JavaScript examples. To start with, well, the question is maybe who is interested in IoT and why are we talking about it here at AstriCon? And I just think that all of these people should be implementing IoT in their products soon. So let's try to integrate IoT now into our systems, Asterisk systems. A basic definition, this is kind of a more official one by the International Data Corporation, states that any network connecting wired or wireless devices or things characterized by autonomous provisioning, management, and monitoring defines an Internet of Things. So the problem is that there's quite a few definitions like this. So what a lot of people think of when they consider IoT, skip the slide there, is that it basically scales. So you have very many devices. You have millions of devices potentially that are speaking to one another. They are autonomous, so they can work without human interaction. This is the typical that we've had for years now. Vacuum cleaner that vacuums your house while you're not even at home, for example. They're resilient, so they're fault tolerant. So if something goes wrong, if there's an unexpected situation, or if a sensor measures a value that's off the scale, they have to keep going, they have to accept that and work their way through it in some way. Long life, so that's a durability, and they're connected to one another. It doesn't always mean that they're connected to humans or machines. It can be either. So the M2M is a idiom for machine-to-machine communication. H2M is human-to-machine communication. You might be using a mobile phone or an IVR system, dialing something in, or some specialized application. To put that in pictures, take a look at what we have in our world today, or mostly today. This is a little futuristic. You don't see this in every city. And it might be hard to read. There's a lot of small text there. I'll read off some of the things. So you have water leakages, vehicle auto diagnosis, waste management, waste quality. There's a fire, forest fire over there. So we've got air pollution, forest fire detection. There's devices that can be used to measure and control all of these things. More in lines of telephony, we have smartphone detection, people in the streets where we might have a beacon detecting people and connecting them together. Some other examples of more concrete devices that you might have in your own homes already. Here's a smart meter. I think it's a gas meter or electrical meter, something like that. So that's connected to the internet, and I think everyone knows how that works. That the folks come by, I think, in their trucks, just run down the street and read the meters off without having to enter the homes. Thermostats. Here's an interior localization beacon, so you don't have to be connected to a GPS satellite for different machines to know where you are over Bluetooth. The drones, we've got a variety of prototyping boards like this one. I can actually pass this around. I think that might be interesting. This one is called the Minnow board. It's kind of a quite beefy example of a prototyping board because it consumes a lot of power. By a lot, I mean 5 watts and more. So this can still run off batteries, but but it's kind of the larger version of the prototyping board. So I'm just going to pass it around. Can you please, after you're finished looking at it, you might want to pay attention to the different things on there. It's got 2 USB ports. One of them is USB 3, so it's it's good, got good speed there. It's got an HDMI out, so it's got video, gigabit Ethernet. Like I said, it's got a lot of things on there. Some other things. Not all prototyping boards are that high powered. This is an Intel Galileo, which has a different processor. That one's an atom-based. This one is a quark-based, so this is only 32-bit and only has 1 core, but it runs on less power. It's got, I think, 3 or 4 watts TDP. And this one has a couple nice features in that, I wish I had my laser pointer, in that you see these black things there. These are actually Arduino shield assemblies. So not to get too much into Arduino, we've only got a half hour, but you can basically mount sensors on here. You can do a lot with these analog and digital rows of contacts. What's a good example of that? Like an LED assembly, or the last place I was at, they had an alcohol measurement assembly. So no, they weren't passing beers around. They were kind of had alcohol swabs, and that's what they were using to measure, like a alcohol breathalyzer application. The one nice thing on the bottom, which you can't see, unfortunately, is, oh, hey, that's great. So you got tired of the strange pointing. So here on the bottom, yeah, you can't see it. Anyways, it's a mini PCIe slot. So the next project I personally have with one of these is to get a GSM modem on there, a 3G modem on there, and a SIM card in there, and then see if this can really be a very autonomous thing, hanging from a weather balloon or something like that. Yeah, so enough of that. I think we'll have to move on. Here's another example. This is actually my personal favorite. This is running on 1 watt only, and it looks pretty big. And there's an example of it here as well if you want to come up later. It's a super tiny thing. This is the size of an SDHC card. In fact, the original design was made so that it would draw power from the SDHC circuitry. You would slide that in to the slot of a computer or something like that. And as you see, though, there's no, it's not the form factor of an SDHC card, because later they changed the design and they changed the processor from a quark to an atom-based, which is a lot more processing power. And it made it thicker, so it wouldn't fit in the SDHC slot anymore. In any case, that's a dual-core, 64-bit processor, and has a Wi-Fi built in, Bluetooth. It's a pretty insane piece of kit. Just to give you an idea of what that looks like or how big it is, that's right here. That's this little small piece. Here's a regular standard size access point, wireless access point. That's about the same size as a Raspberry Pi. This tiny thing, I've got a piece of tape on there, and that's why you can't see it. So that's actually the same thing. That is exactly what we're looking at here. It's just a little easier to see. So once we have this, there are some other types of IoT devices which are wearables. Now the jury's out on whether wearables really do fit the definition of IoT. It's always human interaction, and I consider it to be a part of the landscape. In any case, this might be interesting because wristwatches are becoming more and more standalone, and the newer ones have GSM stacks on there, so they can transmit to Asterisk PBXs and SIP proxies. So this could be an interesting thing for manufacturers to think about. Another thing that's maybe relevant is earpieces. So with microphones, I'm going to get this mouse out of the way. Earpieces and microphones. And time for a pop quiz. Speaking of wearables, what do you think a band stands for? Small tip there is that it connects stuff. Does anybody have any idea? Exactly. A band stands for a body area network. I heard that for the first time in China last week, and I thought it was a joke. Folks from the standardization bodies were talking about that, and one mentioned a band. And so, but it's actually a real thing. If you look that up, you can find that, and actually FCC has a frequency spectrum for it. So it's regulated and pretty much, yeah, it's a real thing. So connecting, wearables. Now, if we know what a IoT is, we might think of what the value behind it is from a marketing standpoint in business. And it turns out that there's probably a big future for IoT devices. So this is a slide that you want to show your boss if you want to integrate IoT concepts into telephony. So we saw the IDC definition before, the International Data Corporation. They're a big player in the analysis, in the market analysis, and they're saying that there's going to be almost a $9 trillion market in 2020. Others like Gartner and ABI Research are forecasting 26 billion, 30 billion devices, and that's just in a little over 5 years, so that's around the corner. And that means that whoever's working on IoT research and development today, they're in the pole position to take a piece of this pie when it starts to mature. In pictures, you can kind of see what that means. This basically means the more color, the more devices. And when we start here in the year 2004, we can kind of see a flat line of personal computing devices, typical things at home, laptops and so on. About year 2010, smartphones are taking off more and more. You get tablets at about 2012, and already we've got a chunk of Internet of Things, which almost looks exponential. It's not exponential, but it really takes off and doubles every couple of years. So from 2010 to 2012, it went from 2 million to 4 million, then 8 million in 2014, about where we are now. And that will just keep continuing. So that's the history a little of that. So there is some standardization going on. If we have so many devices and there are going to be a lot of manufacturers, we need a forum where people talk to each other, and there's problems to solve as well. If we have 30 billion devices, then we run out of IP numbers, for example. Are we going to mandate IPv6 or something like that? The standards don't exist yet, but we do have a standards committee called the OIC, or the Open Interconnect Consortium, made up of a pretty good number of, this is only a small subset, but here's the big players are Cisco, Intel, Samsung, MediaTek, ADT. This one is one we know of for home alarm systems, but they actually do a lot of home automation as well. So they're jumping on the bandwagon as well. Dell, Acer, Realtek, Wind River, Atmel. So they're all doing that. And the nice thing, at least one of the guys from Intel mentioned to me that they're not gonna lock this down to an industry-only crowd. They're going to, it's always, all along, it's been kind of embracing the hobby user, the student, the enthusiast, the person working in his garage on spare time. And they want to continue that. They want to keep a very creative atmosphere for IoT in the future. So they're going to release open source documents, which means that anybody can pull those down and implement IoT into their systems, like we do for Asterisk, which is my hope that the Asterisk team will at some point, if they think it's valuable, merge patches, maybe not into the core, but into modules. Right, so, and some of the problems that they're trying to solve are, like I said, IPv6, because you have too many devices for the IPv4 spectrum. Right, it's a new security model as well, because especially when you have machine-to-machine communication, no human is involved. If the data is crossing state boundaries or something like that, juristic boundaries, then you have to think about, well, there's no way to opt out. So if that data is health data, going from an insurance provider to a manufacturer or something like that, you have to have some kind of legal framework and some security framework to secure the data, right? Just a few examples. They're probably dealing with dozens of things, but junk data that goes in databases, so many devices, they're always probing sensors, and they never throw anything away probably, so you're going to end up with a lot of junk data in databases, and you need to sift through that in some reasonable way, maybe with some kind of big data analysis. So they'll be considering the different kind of telemetry protocols, which is basically messaging or signaling across sensors, probing a sensor, getting a value from that, and either storing that or pushing it on the network wire. That's what telemetry means, and they need to choose a protocol for that probably, if they're going to standardize that. There's a few examples that we'll see later of what telemetry means and how we can build a gateway to SIP or something like that. And for an example of telemetry, we have MQTT. It supports both UDP and TCP, so are they going to mandate one or the other or make them both optional? We don't know that. Bluetooth, Zigbee. Zigbee is kind of a contender to Bluetooth, which we all know. But Zigbee is, for example, very useful in home automation because it has kind of a repeater function. So if you're near the toaster, which is an internet thing, and it has a Zigbee transceiver, then you can basically pair your smartphone with that if you're out of range of the access point in the house and still access the Asterisk PBX on the other side or something like that, because Zigbee has a repeater function that helps you bridge that gap. So what do we have with Asterisk in particular? Because all of this is kind of abstract and it's hard to understand how Asterisk can maybe manipulate an Internet of Things or participate in one, or the other way around, an Internet of Things node. How does that participate in an Asterisk PBX? Now here's just a few examples. You could have IP cameras that are more smart in nature, that use live AV or open CV or things that you build in your own systems, and communicate with an Asterisk PBX over a SIP gateway or something like that. Home automation is an easy concept to understand. If there's a place for SIP to calling into an IVR system and seeing if the windows are open or something like that. So I think we'll move on because these are just examples. So hardware choices, if you want to experiment with IoT systems. I already mentioned a few and showed the pictures of them. Where's a Minnow board now? Have you all gotten to see that, or has that left the room? Okay, so have you seen that? Yeah, everyone got to see it? Over there, okay. Yeah, so basically I've grouped these kind of, just to give you an idea of, I mean, if you have an old Raspberry Pi lying around the house, that's a perfectly valuable device to get started with on IoT. You've got a lot of libraries on there which are useful, and you can load, of course you can run Asterisk on there, and some of the telemetry protocols and brokers. So that's what we have here. These are all ARM devices, ARM-based. Pretty much everyone knows what those are. And these are the kind of newer generation of Intel devices. The Minnow board is over there, and I've already mentioned the other two. These are kind of nice because they're very open. The Minnow board, for example, you can even replace the BIOS. You can hack the BIOS, you can replace it, you can put core boot on there if you want, which is probably very interesting if you're making an autonomous robot of some kind, and it needs to reboot or something. You want to know that the BIOS is flexible to do that. Give you a few extra features. So I think I did show the Arduino shields. This is very useful because there's thousands of different type of sensors, and they're all Arduino capable. So an Arduino is a microcontroller device. It's actually not something that you can run Linux on, which makes it a little difficult for, if you haven't used it before, you can't run Asterisk on it. It can't really do much with SIP. But the shield assemblies are very valuable because they're sensors, they're dumb sensors. And that's something good to get started with. All these things are really cheap as well, by the way. I think everyone knows how much Raspberry Pis are, $35 or something like that. And all of these are about the same price. I think the Minnow board is the most expensive because it has so much kit on there. It's probably about $100. And the other two are run about $30 to $50, right? Don't forget, if you're going to implement PBXs in consideration of IoT, that you have wearables as well. So a lot of times you can leverage the work that you've done for mobile applications on smartphones, tapping into SIP proxies and PBXs, and just carry that work over to wearables as well, which is a big market in its own. So an example IoT stack, what kind of software that you might find on a new device, at least a development device. Typically, you really slim it down if you're going to have something running on a battery and it needs to be very reliable. But in a laboratory environment, you might see some of these software pieces. I took this list actually from an IoT profile that Tizen is developing now. It's an Android contender, and they're doing things for IVI systems on cars and mobile phones. And basically, they want to get in the racket as well. So this is their IoT profile. They have the Linux kernel. They have BusyBox instead of Bash. It's a little, there's a lot of things here that are replacements because they're slimmer, right? So BusyBox is the shell. They've got DropBear for the SSH server so that you can SCP in and out files and so on. Blues is the typical Linux Bluetooth transport, and then Conman for IP, for Internet Protocol and manipulating DHCP and so on. Ophono is the 3G transport. So you can have a 3G modem for your IoT device. And then this is interesting. The Mosquito is the MQTT broker. This is at the middle of a lot of IoT devices. And that's on there as well. This is actually not true, but I put it in anyways because I'm going to add this to my own setup. So there's no SIP on the real one, but on this example I kind of manipulated. So this is the media layer. You've got mini-DLNA, libav, and OpenCV. These are the kind of optical recognition. So if you have a camera sensor on your IoT device, then you can basically tell if the door is open or closed, if there's a package lying on the front door, if that's a dog or a human that's walking in, you know, all these kind of things. Then you've got some databases and file servers. NGINX is really slim HTTP server, which can probably serve files as well. And at the bottom here, we have the generic programming layer. So that's where you can build your applications with. Some people use Python, others use JavaScript, so we have a Node.js on there. Actually, quite a lot of people use JavaScript when they develop for IoT. All right, and the messaging protocols that we have to choose from, if we have different IoT nodes and they need to talk to each other, there's no standard yet, but probably there's going to be some of these on the list. SIP is not very popular, so that's something we need to take care of, I think. But in the meantime, if we need to build a gateway or a proxy of some kind to translate between SIP and these other messaging protocols, I think that's doable. Basically, to mention, well, to start with, we all know what a star topology is. That's a typical Asterisk PBX server in the middle. Then we have the UACs, UASs that are around and connect to it, register and send and dial and so on. So that's easy. And what's really nice with IoT, if you have a network and you're designing an IoT system, is to raise the resiliency by maybe taking on a mesh type of topology where if you have an IoT node that goes down, for example, in the example of the forest fire, if the temperature raises too high and it just can't function anymore, that it doesn't take the whole network down. You know, if that's the middle of the star, then that would just mean the whole thing breaks down. So that's where mesh topology is very relevant for IoT systems. Now, MQTT is the protocol that we saw before, and that's basically like SIP, but very specialized for sensors and messaging between devices. It's kind of hard to explain, but it does have a couple features like topic nesting. If you have, if you're communicating between two humans, for example, and the message is a speech message or a text message, then you might want to form a group of people. And so the first topic you have is humans, the second could be family members, the third could be siblings, and the fourth could be female siblings, so those are your sisters then. And you have this nesting, this hierarchy of topics then. And then you send to this one hierarchy of topics, and it kind of it doesn't broadcast, but it publishes, and any other node which is listening to the broker identifies if it belongs to their category, and then it reaches, your message reaches exactly those participating nodes that you intend to reach. And that's what I mean by nesting. It's, yeah, that's one of the nice features of it, which SIP doesn't have. Quas is another thing that it has. When you're using TCP, Quas is not so relevant because it's already very reliable. CoAP is very similar to MQTT. It's another telemetry protocol, which is more popular in the commercial crowd. So Cisco is supporting CoAP, for example. I think that SIP could be very useful, though, for messaging. What we have, I mean, MQTT was popularized by the Facebook Messenger. This is carrying all communications for Facebook between people using Facebook Messenger. And so you can understand where SIP would play a role in that as well. People communicating with each other, you know, sending SIP info messages, or even dialing in and doing voice on an IoT network. I did put the Skynet framework on here as well because the guy developing that is a friend of Asterisk. And a few of you might know Chris Matthews, who's just not too far in Phoenix, and he's developing Skynet, which isn't a standard protocol or anything like that. It's kind of a jumble of technologies. But he got the idea early on with Arduino devices that they should all connect, and develop Skynet for that, which, in my opinion, belongs to a messaging framework. So those are the type of ideas that we have for messaging. How much time do we have? Let's see. Oh, okay. So as far as message management, this could be very important and interesting as well. If we have IoT devices which are trying to leverage features of an Asterisk PBX, then they have to communicate with it in some way. And I think AMI is a good way to do that. But it seems to me that ARI is going to take the cake here because of its web nature, and it's going to be really easy to use from IoT nodes. There are a couple of good examples of mature IoT-like Asterisk JavaScript modules. So this is from the NPM repository, and one is called Asterisk Manager. The other one is called Asterisk AMI. And we have an example of Asterisk Manager a little later on. It's maybe the more popular of the two. But I started thinking about this, and I'm doing this in my spare time, so I didn't have time to really make any Asterisk modules yet. But as far as POSIX modules go, you know, writing in C, C++, I would think that there is some interest into the future of being able to just write dial plan applications in the easiest way possible, as long as you have the right modules. And these are kind of some examples that I can think of. OAC, don't forget, this is the Open Interconnect Consortium, so they're going to create a standard, and we don't know what it is yet, but if we implement that standard, then we could have a resource for it. We could have a specialized resource for sensors covering the typical use cases of measuring temperature or open doors, door locks, and so on. And I even put a door lock application down here that, you know, that could be like a user friendly, you know, anyone who has some special thing in their house, and a lawnmower or something, can write an application for that. By leveraging the IVR module, you just look at the code in there and you can probably do a lot with it. There's RFID and NFC are very important things in IoT. So if Asterisk could identify objects via RFID codes and NFC tags, that would be very useful as well. This is kind of just daydreaming, you know, this is like Alice in Wonderland. But then we have the two transports, these telemetry messaging transports as well, which could be channels. So enough of that. Are you awake now? Yeah, I wanted to do live demonstrations, but they all work on this thing here, and I think there's no time. I'm just going to basically show the code that works on some of these devices, like, for example, the Minnow board. What you have here is JavaScript. So I think that's big enough to read. This is a basic, what is it? Okay. Okay, this is a basic example of MQTT. So you can see here that MQTT is being required. This is really the only part of this whole thing which is, well, it's all JavaScript. I'm sorry. I was going to say there's only non-standard JavaScript part. This is, you know, when you require something, that's Node.js. So Node.js is kind of a way to run JavaScript outside of a browser. So if you have an IoT device that probably doesn't have a browser on there, you still want to use JavaScript with it, then you need some kind of framework. And that's why Node.js is so useful for IoT programming. So basically what we have here is we want to publish MQTT messages. For example, the Facebook Messenger, sending something to your friend, to your sister, or something like that. So you want to use the module. You pull that in with this require statement, instantiate it with create client, and then you get back an object that's local client. And so what you could do with that local client object is publish messages with it. Publish, 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 and then you tell it to flush the cube with an end. And what you can do is, so the messages here, that's the topic, that's a category. That's like a free text field. You can write in there messages or voice or robotics or whatever you like. And that's the topic. So in the next slide, we'll see that people subscribe to these topics. And then this is the real text that gets sent and people read on their devices. In the case of Facebook Messenger, they would see that pop up on their screens, right? I wish I could show that. Anyway, this is, go back to screen. Whoa. I've never seen this. Sorry about that. Let's go there. Cool. That's a new feature. Anyway, so this is on the other side. This is the person who didn't send the message, who didn't publish. This is a subscriber. Those are the two types of participating people or nodes or whatever in an MQTT system. And this one is subscribing to a topic. So here we have the same stuff boilerplate at the beginning, and then you subscribe to the topic messages, which we saw before. And you can publish as well, but if we have here, this is the way you get messages printed on the screen, is console and log, and it basically will show you what's coming across the wire over the MQTT broker. This last example, if we can even see it. Yeah. Cursor is not what we want in this case. Let's go back down here. So this is a little bigger, but this is the same Node.js framework for an example communicating with Asterisk over AMI. We don't have much time, but it's basically, you can see a lot of similar things. Here we have the require, and this is the module name, Asterisk Manager. And there's a port and a host that you need to fill in. These are numbers, actually, IP numbers, passwords, and so on, so you have authentication. And then you basically want to, this is the event name that you want to listen to. And like it says here, you can actually see what all the different events are that AMI supports. This is an old version, but this should be 13 here. Anyway, down below, this is the typical command that you can send to the Asterisk PBX via the AMI. So anybody who has programmed with AMI before, you know kind of how this stuff looks and what you can do with it. That was that. Some resources that help to get started with IoT are, for example, this book. There's not very much because it's very early on, but this is actually not too bad because you can download it, check it out, and then buy it on paper if you like it. I think it's a good one too. It has some non-technical things as well. So incidentally, all these slides, I'll give you the URL. It was on the first slide as well, and you can, it's online. Here are some other things that we talked about, like the Edison Node.js, MQTT OIC, Skynet at the bottom. And just to finish up, there is some danger with IoT as well. We just need to make sure that we do it properly. Otherwise, it takes over the world. There's some security problems as well.
Sir? Shall I?
No. It's my job now.
Skynet defense system
We're in.
now activated.
We're past the firewalls, local defense nets, Minutemen, and subs.
Skynet fully operational, processing at 60 teraflops a second.
Sir,
it should take less than a minute to find the virus and kill it.
All access inquiries to your supervisor.
Let's pray to God this works.
Skynet defense system now activated. Please
Power failure? No. I don't know what it is. Tony.
Oh, well, what comes next, you just have to imagine that, because that's the way it is with IoT. It's very imaginary and futuristic, isn't it? So that's what we talked about. I don't know if we have time for questions. Unfortunately, we don't. But there is, you can scan the URL there. So it's actually here. That's a URL. Yep. And all slides are online. Thanks a lot for coming by.